Hello everyone. GM. Thank you so much for joining in. So yeah, today we have Marcello with us, and this is a part of Twitter Spaces where we discuss into interesting technologies, upcoming technologies, and the projects in the StartNet ecosystem. And so this is how the discussion will move forward. Let me just break down the structure of the call, right? So we'll have the introduction, and then we'll be having some questions. We have some questions set up for Marcelo to know more about what Press does and what the storage groups. And then next up, we'll have some questions from you all, which is the audience. Then we'll have the summary, and then we'll have the closing word. So we at Hashtag are creating a permissionless under collateralized lending solution for crypto retail where you can get up to 3x loan on your collateral. Guest project which we have for today is Herodotus, and they provide synchronous access to data from Ethereum layer 1 to the likes of StarkNet. And here we have Marcello Bardus, the CTO of Herodotus. Glad to have you here, Marcello.
Hi, thanks for having me.
Hi, Marcello. Hi, Herodotus team. It's a great pleasure to hosting another very interesting project which builds very crucial infrastructure products, and this is always a great occasion for the audience, but also for us too, to deep dive a bit and learn things that we haven't and we aren't very familiar probably yet. So all these spaces we are doing with regards to projects inside but also sometimes outside StarkNet Eco are meant primarily for spreading the word of what we are building and what our fellow project is building, but also to be educated better. So hello, Marcello again. Welcome to our Twitter Spaces. So let us begin with an introduction about you, your team, of course, and the story behind your project's inception and the vision behind what you're doing. How big is the team? Where, in what timestamp you thought of making Herodotus? How did the name came? Because it's of Greek origin and it's very interesting to me also. So please take the stage and
Sure. So thanks again for the warm intro. So maybe I'll quickly introduce myself. So very briefly, I'm essentially the tech guy at Herodotus. I think that's enough context. Like I do from engineering the systems, like some cryptography, and essentially a little bit of everything. Okay, cool. So maybe a few words about Herodotus. Maybe before I dive more deeper into Herodotus itself, I'd like to give some a little bit of history, and we're going to talk about history quite a lot today. So maybe I'll start by just talking a little bit about blockchains. So kind of smart contracts give a lot of adoption and usefulness to this technology in general. And it started from the very basics, where Bitcoin was just application chain essentially, and then we ended up building smart contracts, and the smart contracts just are unlocking a lot of innovation. But at Herodotus, we believe that this can be taken a step further by just providing and enabling accessing data that was just not possible before. Because when you think of it, currently, essentially all these chains that are able to run smart contracts, they have a VM, right? And that VM is pretty limited for some very technical reasons that I will dive a little bit deeper later. And they can only access the current state and to some very, very limited extent the state of other smart contracts and also smart contracts on other chains, but it's all right now at the same time. And we very, very deeply believe that this can be changed, and changing that will just enable many applications. So that's what we do, and we believe that this should be simple. So for that reason, we want to propose a way to access this data, I would say, in a synchronous manner. And now a few words about why we're called Herodotus. So Herodotus was actually a historian, the father of history, and supposedly he built the Herodotus machine, which was used to build the pyramids. And Cairo pyramid start, and it just fits pretty well. So we thought that it's not. And about the team, we are like around 10.
Great. Awesome. Okay, now let's start digging a bit your technicals. So, and I want to ask you something, if you can, to because you are a dev, and this is highly technical sector that you are working. Regarding to Herodotus project. So, if you can break it down so everyone can get a sense of what all these terms and processes are all about, it will be great. So at your own pace, of course, can you tell us how does the proof verification process work, and how are you implementing that in Herodotus?
Sure. So maybe I'm not sure if I specified that we provide only on-chain data as Herodotus, meaning that any smart contract now will be able to access some data from, let's say, 1 year ago without introducing any new trust assumptions. Essentially, this whole procedure can be validated by the chain itself. So that's like, long story short, what we want to achieve. And now let me tell you a few words about how we actually achieve that. So we think that blockchains at the end of the day are just databases, but pretty unstructured, at least from the perspective of standard database systems, where essentially you have one layer which is just blocks and a chain of block headers, and then depending on the specific architecture of a blockchain, well, let's look to Ethereum, which is stateful and is an account-based model. We have so-called smart contracts that can also have their internal state. Essentially, this state obviously needs to be somehow saved, and everyone in the network should be able to validate that. And for that reason, you use very weird data structures. Under the hood, you just use a very simple database, but this database is committed in a cryptographic manner using some trees. I don't want to dive super deep in the structure of the tree, but the nice characteristic and property of that is that essentially anything that was ever present on the chain can be proven in a cryptographic manner. So this is like one layer of what we do at Herodotus. We essentially just leverage this very, very basic and low-level properties of Ethereum itself and also other blockchains to enable verifiable data feeds. But obviously, as you can imagine, this is quite expensive because it requires many proofs. The verification is pretty expensive. And this is one of the reasons why we are using this, new paradigm, I would say, even in computer science, where we just can do some computation and prove that it was done correctly, and the verification is way, way, way cheaper than performing the computation itself again. Essentially, this combination of these two facts. So, quick reminder, first fact is that everything on the blockchain is verifiable because we just use a lot of cryptography and very basic cryptography, like commitment schemes. And the second is verifiable computation. And by having a combination of these two, we are building Herodotus.
Okay, great. You say, and I quote, "Our stack combines storage proofs with zero knowledge proofs." I was wondering, what benefits are you harnessing with this combination? And if you can close your answer with an example, practical example.
Yeah, so like I just mentioned, first, storage proofs allow us to prove that anything was ever present on the chain, but verifying that is pretty expensive for a bunch of reasons that I will cover in a second. But verification is always computation. Computation can be also proven with zero knowledge proofs. And we sort of do that. So now to dive a little bit deeper into that, storage proofs are essentially just proofs and paths in the tree. And well, as you can imagine, the state of Ethereum is pretty big. So also these proofs are pretty big. And if you want to verify them, you need to put on the chain, right? Because it's the chain that is gonna kind of ingest that data at the end of the day. And well, bandwidth is pretty expensive with blockchains. Why? Because everyone just needs to store the information such transaction happened. But here we can leverage a very nice property of zero knowledge proofs, is that essentially we have something that we call private inputs, and this is something that is not needed and is not necessarily revealed to the verifier itself. And quick reminder, in this case, the verifier is the chain itself. So you can kind of hide a lot of data, but still kind of prove that whatever was provided to this circuit, to the zero knowledge proof, is actually valid. And by just having no trust assumptions, we can still access that data. And yeah, this is a pretty practical example, but gives something very, very concrete how this plays out. So maybe let's talk about a little bit about StarkNet. So as you know, StarkNet is a rollup with very nice properties, where call data, aka bandwidth, like I like to call it, is not directly posted on L1, meaning that there is no L1 footprint. So what we ended up having on StarkNet is a rollup with a lot of bandwidth. So it's just perfect. And again, every single computation on StarkNet is proven. So we can just verify a bunch of proofs on StarkNet and literally access any piece of state that ever existed on Ethereum mainnet and also other EVM-like chains. So I hope that answers the question.
Yeah, definitely. So as a conclusion, you are leveraging the efficiency of zero knowledge proofs that come with, of course, deploying on using StarkNet by reducing very much the size of the data needed to have to retrieve this and to retrieve this information and provide your proof.
Yeah,
correct.
We actually internally we call it compression. So yes, that's a very good way to put it.
Okay, compression. I like that. All right. I'm pretty sure everyone until now, even if we are a bit early in this conversation, has understood that the tech stack you're using is quite complex, and implementing such solutions is also very challenging. I wanted to ask you, were there any challenges that you faced while operating proofs on chain? And if you did if you did face some big challenges, how did you manage to overcome them?
So maybe before I will talk about the technology itself and this set of technologies that we use and tools, I would just like to underline that a very important, or even the most important thing that we do at Herodotus is reasoning about like the nature and the design decisions taken in the past by whoever designed these underlying protocols, which are blockchains. And the reason why I'm mentioning that is because we really need to like think deeply what is actually valued on a specific chain and why people want to use it and why it was so successful or so unsuccessful is because of, what are the trust assumptions, what you can do, what you cannot do, and so on and so on. And obviously that needs to be reflected in how we actually design our stack to support this specific integration or the specific, I would say, features, data feed, and so on and so on. And it always comes back to some questions about like data availability, liveness, censorship, and so on and so on. So I would say there is a pretty significant philosophical component behind our stack, however that sounds. Mm-hmm. And now regarding the technology itself, we use a variety. So we use from Starks. Obviously, we also have some backend solutions, and these are also like written in some technologies that allows us to scale. I know if you want, I can mention some programming language, some frameworks, but I'm not sure if this is some information that is needed.
Feel free to mention them, because we might have some devs here attending, so it might be useful to them.
Sure. So maybe at the beginning I mentioned that we want to provide data, access to historical data, and a blockchain is a database at the end of the day, but again, we want everything to be verifiable. So the information required to the verifier should be minimal, and again, the verifier is the chain itself. So obviously that's a lot of computation, as you might know. Like one of the most feasible solutions to prove the correctness of a significant amount of computation are Starks. But then when it actually comes to consuming the data, you obviously want the verification cost to be as low as possible, and this is not possible using ZK Starks, at least nowadays, because of just a significant amount of bandwidth that is required. And for that we use snarks, which are very, very cheap to verify. And the major reason behind it is that they are very, very tiny. And well, some of our circuits are written in Ethereum, and also like a few other technologies that we are considering. But for starts, we mostly use Cairo.
All right. Actually, I wanted to ask you about that, but you covered that. I mean, regarding why using snarks and starks at the same time, but it's a matter of cost. Okay. You got me here. So you also mentioned synchronous. You are using synchronous approach. Okay. So we have synchronous and asynchronous approach. Can you tell us the key differences practically between these two, and why the first one is more favorable to you?
Sure. So maybe I'd like to just cover why we call it synchronous and what is also the definition of these two. So maybe before we actually start defining synchronous versus asynchronous, let's set up some definitions. So it really depends on the perspective and who's looking at the process. So we assume that synchronous, whenever we mention synchronous from the perspective of the chain itself, it should be synchronous. Meaning that whenever we implement a smart contract, you just for some reason have the data and you assume it's correct because there is an underlying proof that just attests so. But yeah, so to give you a concrete example, you're just writing a smart contract and you can simply get the data and use it. And then asynchronous approach is like, for example, when you use things like oracles that were first you need to request that, hey, I want this specific data feed, and then after a few blocks or even in the same block, you might receive back a transaction that kind of is like a callback to your contract itself. That's something that we call asynchronous. As well as designing like asynchronous protocols is always tricky, and it prolongs the engineering time very often, and most importantly creates some security risks because the designs are just more complex. Like we really want to avoid that, and we want developers to just think very deeply about the application without caring about the underlying infrastructure, designs and so on. So that's why we deeply believe that that synchronicity is pretty important, at least from the perspective of the verifier itself and the end consumer, which is the smart contract in our case. Yeah, but under the hood, some many things might be actually asynchronous, right? Like, for example, the way how we generate the proofs and so on and so on. But this is something that we completely hide at Herodotus. We don't want people to even think about it. We want to make it as simple as possible.
Yeah, I totally agree with you, and I applaud that. So asynchronous is kind of you are having a direct approach and relationship with regarding to the transactions you need to do, and asynchronous is when you go around the block, as you say, and a third party or even a fourth party is getting in the whole process. So let's see a bit regarding to cross-domain data access. So you are doing cross-domain data access between Ethereum layers and also other chains, correct?
Mostly
between Ethereum layers. Okay. How does this work? What is this exactly?
Sure. So I mentioned before that we think like very philosophically at Herodotus about the things, and we believe that Ethereum is sharded nowadays, because like back in the days, like many years ago, there was a huge debate around the sharding. Okay, what if I deploy my application to this specific shard, but for example, some contract that I really need to interact with exists on this shard? And like again, here we have a question about like synchronicity or asynchronicity. And we really believe that Ethereum needs to be sharded because it just scales well, and this is how we can onboard more and more users and be successful in the long run. But at the same time, we lose a lot of convenience for developers, and also applications and their design become way more complex. And for that reason, we really believe that this should be fixed. And again, the tools that we use to fix that is essentially just cryptography. Yeah, and now how it works, we really want smart contracts, like for example on Starknet, to be just able to access some data directly on L1 without the need of like sending a message from L1, then to consume this message on Starknet, then do something on Starknet, send it back to mainnet, and so on and so on. We really want to remove this graph-like complexity.
So you simplify something that before it was being done through the around the block process, okay, and with middle projects helping to facilitate, correct?
I would more say we make it completely abstracted what leaves what roll up. Like we just believe that Ethereum should stay Ethereum without a big difference between if it's like, I don't know, Optimism or Arbitrum. We just believe that applications should just take the best of Arbitrum and Optimism and use some resources that are the best being available, let's say Starknet. I really believe that this is the way to go, but obviously that requires a lot of tooling, and Herodotus kind of plays a role into that vision.
But you're obviously having that.
Yeah.
So we're talking about speed, transparency, and efficiency. Can you share with us some of the on-chain data with Herodotus support, and which chains are you compatible with as of now?
Sure. So maybe let me talk a little bit about on-chain data, generally speaking. So, a blockchain is essentially a bunch of blocks and block headers. And these block headers can have some properties, like, for example, timestamps, state roots, receipts roots, transactions roots, base fees. For example, withdrawals hash recently added on Bitcoin, it can be, for example, the Merkle root, is it called? Essentially the root of all the spent UTXOs. So it really depends on the architecture, but let's focus specifically on Ethereum. So I mentioned like block headers, but we also have like the tree of the stake itself, because on Ethereum we have, I would say, 3 main things. So obviously we have transactions, so it's just about the bandwidth that was kind of submitted to the chain and all the transactions posted there. Then we have receipts, and receipts, I like to call them like the result of the execution of some specific transaction. Like for example, I send a transaction to USDC, making a transfer between Alice and Bob, and the resulting information is that some tokens have been transferred from Bob to Alice, and we might be willing to access this data. And last part, probably the most important, is state. And the state is, like, for example, information about balances, information about prices on like Uniswap pools. It can be essentially anything that you can just think of whenever you like write a smart contract in Solidity and you just save it. This is literally the state. It's anything like NFTs and so on and so on. It can be nonces, even smart contracts bytecode, and so on. And most importantly, every separate block can have like a separate state, right? Because like my balance can be different today than it was a few days ago. And obviously you can access like the data with Herodotus. And about the chains we currently support, so we are live on like Starknet on testnets, so you can play with it already. We support Ethereum, and in the coming weeks you will be able to like access also data from other rollups. And soon you'll be also able to use Herodotus on EVM chains.
Great. And you will combine a cross-chain ability in all of them, I guess.
Yeah,
correct. All right. Very powerful tool. Adding to my previous question, what use cases do you obviously share with projects that you are talking with? So what are the use cases now, and what is the expansion of them in the future? And from our side, since we are a DeFi protocol, we would love to elaborate on the DeFi use cases also.
Sure. So maybe I will start by talking about our, I would say, flagship integration, which is SnapshotX. So, like long story short, SnapshotX allows its users to vote directly on the chain. So, the things like censorships and so on, counting the votes is addressed directly by just, doing the whole computation on the chain. And well, guess what? Doing that on the one would be pretty expensive. So, a natural solution is just to do it on an L2. But it comes with a problem because, well, to vote on Snapshot, depending on the strategy, but in most cases, you need some tokens. And these tokens are probably on L1. So now you want to vote an L2 based on assets you hold on L1. Okay, so what you can do? Well, you can bridge them, but then you're relying on the security of the bridge. So that's already problematic. And well, to bridge them, you need to interact with the L1 to then vote on the L2, bridge them back to L1. It's pretty annoying, and very likely most users will just give up and won't participate in the specific voting. Well, second approach, we can just send a message from L1 to L2, but then it's about bridging information. So again, we need to interact with L1, send the information to L2, do the voting on the L2, and then send back the results to L1. Becomes kind of problematic, and also like the design itself becomes way more complex. But hey, we can do something better. What if we just let those users prove that they hold some tokens on L1 without even touching? So we can reap out the utility of some assets we hold on L1 without ever interacting with it, which is a pretty powerful thing. So that's one example on the governance side. And about DeFi, so I definitely think the data feeds will be pretty interesting. So for example, you'll be able to access TWAPs calculated with on-chain data directly. Another thing, today is pretty hard to just check what was the volume on, Uniswap V2 in the last 7 days without using an oracle, which is an off-chain system, usually. And well, with storage proof, you can just prove it directly, do the computation, and suddenly you have a trustless data feed, which is pretty powerful. And you can, for example, build an insurance platform where LPs can literally bet what will be the volume in the next week, and that way just hedge themselves. And then so on and so on. You can, and now this is about historical data, now about cross-chain data access. You can, for example, prove that, hey, I'm an Optimism, but I have some assets on Starknet, and I would like to take a loan on Optimism, but my collateral is on Starknet. Well, so I can just post a proof on Optimism that attests that I have some assets on Starknet, and for example, log them inside the CDP. So yeah, that's another use case from the other angle, which is data access.
Mm-hmm. So a question just bumped in my mind now as I was listening to your answer. So very important stuff, very interesting stuff there. So regarding governance, if a project doesn't have a native token to be used in a DAO structure, so to use your native token as a governance one. So yes, this could be a very good solution. But let's say that yes, you can verify, you can prove that the user, for example, has some assets in Optimism, but wants to vote on another chain. So what is the safeguarding process that, although I as a user pledge that, and you can say and verify that I have in Optimism some assets, but what prevents me from selling my assets, after voting and without having to pledge the amount I initially said that I will?
And this really depends on the voting strategy. As for others, we don't want to imply any application design, we just give the tool. It's definitely on the voting strategy to think about the problem.
Okay, so it's a matter of the project itself. How will utilize your technical approach? All right.
Yeah, correct.
Okay, So that definitely relieves the burden of your shoulders, and you can be clear regarding we provide you, do the best you can using that. So yeah, awesome. All right, continuing in the same narrative, so regarding safety and validity, can you guarantee the validity of the data which travel through your infrastructure at any time?
Yeah, any piece of data that travels through our infrastructure is always on-chain data. And very important property, the latest block hash of the latest block on any chain is a commitment to the full history of the chain itself. And that said, by just trusting this small 32 bytes.
Sorry, we lost you.
Yeah.
Sorry, Marcelo. Can you repeat, because we lost you?
Yeah, sure. So to answer your question, a key property of blockchains in general is that the latest block hash is always a commitment of the full history of the chain itself. So by just trusting this single 32 bytes of data, we can essentially verify anything that ever existed on the chain. Obviously, this comes with significant computational overhead, but that's exactly why we use ZK snarks and ZK starks. So to answer your question, any data that travels through our system is on-chain data, which is proven to be on-chain.
All right, so the guarantee is there. Awesome. Regarding the costs, okay, all these nice things you are describing require medium or big computational and also a lot of infrastructure maintenance from your side, updating, of course. Maybe you will require to hire more as you progress and you evolve with new features. So what are the costs for a project to use Herodotus?
Sure, so maybe let me answer to your question from different angle. So I mentioned that all these data feeds obviously require a lot of computation because they require proof. But like again, different data feeds might require less on-chain data or more on-chain data. So to give you just an example, when I mentioned governance, we very likely just want to access some balance at a very, very specific point in time. So at the end of the day, for one user, we're proving one balance. But like, for example, let's talk about DeFi, where one specific pool to settle might require some information about its volume in the last 2 months. So obviously what I need to do as a prover is literally walk through every single block in the last 2 months, filter every single receipt and check what was the volume. This might require way more computation. So again, the fees really depends on the data being accessed. And also another dimension to add on top of that, as we use ZK proofs, and there is a very nice property that essentially one proof can serve like multiple users. So a very similar idea that exists on ZK rollups, that essentially the more people use them, the cheaper it gets, right? Because the prover will just generate a bigger proof and the cost of verification is sublinear. It works very, very similar in our case. So we kind of identify some hotspots in our data. And the more some place is hot, then cheaper it is to access it precisely. But like again, we're still thinking about a fee market for Herodotus, and we don't have any exact numbers yet. But one thing is for sure, our cost won't exceed the gas cost of doing this whole things on your own. aka like generating the proofs, verifying them, and so on and so on. And the reason why we can commit to that is that essentially, again, we can batch multiple things, we can aggregate, and that drives down the cost significantly.
So, if I understood correctly, sorry, you said you're more or less, unofficially, although we are recording that, but I can promise you won't use any of the information against you. So you said most probably the cost will be in the height of the gas fees and the
Plus proving cost.
plus proving cost. Okay, so yes, so you are going to batch all the transactions, and yeah, you will make revenue from that. All right. Yes, that seems a good scenario to my eyes, at least. All right. Finally, let's hear a quick update on your current state and, of course, your near future plans. So, throw us everything you think it's important for us to know, and if you can share some alpha, we would appreciate that.
Okay, sure. So definitely, I encourage everyone in the audience, especially technical people, to test out our APIs that are currently available on Starknet. So just go to docs.herodotus.dev and check it out. So that's one thing. We're obviously doing many optimizations in the background, so the experience will be even smoother. And now regarding our plans, soon we are gonna be also on EVM chains. So those who don't know and don't want to be on top of Starknet will also be able to like benefit from Herodotus by just using the stack they're familiar with. So this is a few words about our plans.
Mm-hmm. And we are talking about this year. You are going to do the EVM opening to more chains, as you said.
Yep.
Mainnet to everyone. All right. Okay. At this point, I would like to ask for our audience to use this very nice opportunity and share their thoughts, their feedback, and of course their questions. So guys, the stage is open. Raise your hand, ask for permissions, and Ayushman will grant you. I want to share that I have already 2 questions in my Twitter DMs. I will ask you later, Marcello, if no one is willing to take the stage. So, Ayushman, do you see anyone? Not yet. Come on, guys.
We have a lot of people
No.
from Herodotus.
All right.
Yeah.
That's very nice. Hello, Herodotus team and Herodotus community. Okay, here goes. Marcello, I will ask you the first question from my DMs. It says, would you consider that we can call Herodotus an oracle? If not, what are the major differences?
So I don't think Herodotus is an oracle. So the first difference is that we don't provide off-chain data. We simply provide on-chain data. And also, like, again, our primary mission is to kind of unlock 2 dimensions of data. So the one is to unshard Ethereum in some sense, and the second one is to literally allow developers to access anything that ever happened in the past, also on like other rollups, other, as I call it, shards. So to some extent, you could think of Herodotus as an oracle, but we can also think about just reading the state of Ethereum to be something in some sense close to being an oracle. So I would say it's to some extent the correct definition, but very, very far from reality.
So adding to that, taking this a step further, would you say that you can or you could in the future be the price data feeds for a DeFi project?
I think definitely one could build something like that on top of Herodotus, but we don't want this type of integrations on top of ourselves.
All right. So you can provide all the tech stack, the platform for anyone to build and obviously scale what you're doing. All right. Okay. My second question in my DMs is around KYC. So, do you think your approach will help with the KYC in the future when it will be implemented by government?
Oh, that's a tricky question. I mean, again, philosophically, I don't like this, but yeah, I mean, definitely, if there is a place on chain that will just say, hey, this address was KYC, then yes, that data can be accessed using Herodotus. So, for example, you could take some, let's call it, government rollup, where the KYC actually happens, and this rollup is optimized specifically to perform any operation required to make such check. If a specific address is marked as verified, then obviously such data can be also relayed to other chains using storage proofs. So yeah, definitely it could be used also that way.
Yes, because from our point of view, generally in DeFi, KYC is a very hot topic. I think that down the line, as the traditional finance and the governments are still raging a war against crypto, and especially decentralized aspect of crypto, they will try to implement a lot of things with some cases that they will try to convince the public that we need to implement that so we can avoid, money laundering or some illicit actions. But using the Starknet and zero knowledge proofs, we can remain, anonymous. We can keep our privacy while still proving the essential things that the KYC needs.
I mean, really, if we would end up in a world where we have a specific upchain for just doing KYC, a very funny and exciting thing at the same time about using storage proofs. So, like I said at the beginning, the proof itself, the storage proofs, that is. Still hear me?
No. Can you?
Yeah.
Let's start over.
Okay, yeah. So.
Yeah, I think we lost you in the middle.
Okay, sorry for that. So, like I said, in this world, I can see that definitely one day we might have application-specific rollup that is built just for doing KYC. And the funny thing about this combination of storage proofs and Stark is that actually, right now we do this compression just to save on bandwidth, but we hide kind of the proof itself, and yeah, that way a user would be able to prove that, hey, yes, I passed the KYC, and this KYC happened on this specific chain, but I'm not revealing you who exactly I am. So yeah, if such designs will become reality one day, yes, definitely, it would be pretty interesting to see that.
Exactly. All right. No more questions to my DMs. So last chance, everyone. Marcello is here. Take advantage of it. Okay, then, Marcello, if you like to add anything that we didn't cover, please feel free to.
Again, I'm encouraging anyone to go and test our APIs.
All right. Agiswan, can you please take over and wrap this very, very informative conversation today?
Yeah, sure thing. So, before we wrap up, let me just let you all know about the Galaxy OET which we have, which you get for tuning to our Twitter space. So, if we do check out the pinned tweet, right? Apart from that, we let me just tell you about a quick 2 to 3 minute summary about our Twitter spaces, just in case anyone joined in the middle or just joined, right? So we have Marcello with us. He's the tech guy. He's the CTO of Herodotus. And Herodotus was actually the father of history, and he was in the Egyptian era, right? And then what Herodotus does is they help you get leverage. They help leverage low-level property of Ethereum and blockchain to enable verifiable data feeds. And as you all know, that anything you do on Ethereum is quite expensive, right? So therefore, even verification of storage proofs, that those and all are very expensive, and they're trying to reduce the expense by using zk proofs, which is one of them is snarks and other is starks, right? So they're utilizing zk snarks to verify, since they are tiny in size than zk starks, right? And then we also learned about the synchronous and asynchronous approach of data in cross-chain. And what Herodotus is doing, that they are utilizing on the user experience to make it seem seamless for the users, and they don't have to worry much about the data from going cross-chain, right? Okay. And then the next thing is that we learned about the use cases of Herodotus, and also that they created Snapshot X, which is voting on chain directly. The next thing which we got to know is that the cost of verifying and proving will be not more than the gas cost, right? How they are doing is through batching transactions, which then reduces the cost, and especially if it's on ZK proofs, then yeah, the cost is very much reduced. And the next thing which they are looking for is, if you are a tech guy who's working and experimenting with Starknet and Cairo, do check out their API and give feedback to them, so that they can get to know what's working, what's not working, and they can actually help you out on in case you're building any project based on storage proofs. The next thing which we got to know is that so the last but not least was that we had a question about if the governments can use storage proofs as a way to store on-chain KYC data. And Marcello did say that yes, we can have, let's suppose we have a government roll-up, and then they can exclusively create storage proofs for that, which can then have cross-chain interaction across chains. That was pretty much it of the spaces. I just gave you a gist of how our spaces went for the past 50 minutes, right?
And please, the socials also are used.
So, am I audible properly, Aris?
Yes, you are. Yes, you are.
Okay. So, we have the Herodotus website at herodotus.dev, herodotus.dev, and their Twitter is at herodotusdev, which you can check it out in the pinned tweet, right? And we at Hashtag, our website is hashtag.finance, and our Twitter is 0x hashtag. We are building a permissionless under collateralized lending solution for crypto retail, where you can get up to 3x loan on your collateral, and we don't check your credit scores.
And guys, feel free to join our waitlist registration. So we're giving out our first batches for approved people to users to try our braindex. So it is exciting times for us, and I hope that you will feel the same. So feel free to enroll and see what you can do, and give us the feedback also. At this point, I want to say a big thanks to Marcello and the Herodotus team for joining in this very, very informative space event. We learned a lot today in a not so easy topic. So it's a highly technical one, but the more we elaborate and the more we hear and talk around it, it's more easy for us to comprehend and feel that we know one more thing around this very, very interesting tech space, which is called blockchain and Web3. So thank you guys for being here. Thank you, Marcello.
Thanks.
Bye-bye, guys. See you all tomorrow. Have a great day.